Welcome to our YouTube channel named as Cat2. I am by Manoj Mahajan. Don't forget to subscribe to the channel as we are coming up with Quantitative Aptitude full course relevant for CAT, ZAT, NMAT, SNAP, and other management interest tests. So we are continuing with the arithmetic module. So today we are going to learn successive percentage change concept. So this concept is important because we're going to use this concept in the other topics also, like profit, loss, and discount. Even you find out the use in the compound interest as well. So let's look at the concept out here. So as the name suggests, successive. So let me look forward. Let's say you have the initial value I, and you have a change of a% increase. So my new value would become I into 1 plus a by 100. So 1 plus a by 100 is the multiplying factor. So we talked about the multiplying factor in the percentage class as well. So you can check those videos as well. Now let's say you have another change of b% increase on the new value. So I have taken the example of two changes over here successive. We are going to look at more than two changes also and how to use the concept. So let's first cover up with the two changes out here, successive. So my multiplying factor would be now 1 plus b by 100. So we are going to drive one magical formula also based on the successive concept. So you know already how to get the percentage change. So what we are trying to figure out is, instead of doing two successive changes of a% and b%, what is the one change we can do over here instead of the two changes? So we are calculating the percentage change from the initial to the final value. This is your final value out here. So in the previous classes also, I talked about percentage change can always be written as f upon I minus 1 into 100. So what we require is the multiplying factor again over here. So can you put the value of final over here is I into 1 plus a by 100 into 1 plus b by 100 upon the initial value minus 1 if I do whole multiplied with 100. So the initial value is going to cancel out. Let's look further what is the result we're going to figure out from here. Let's multiply these two. So we are going to get 1 plus a by 100 plus b by 100 plus ab by 100 square minus 1 if I do into 100. So ultimately we're going to get this result a plus b plus ab by 100. So we can look forward to use for two successive changes a plus b plus ab by 100. That is going to give me the net change for two successive changes. So over here we have to understand with some example also. So let me take one example, a very simple one. You have the initial value y, and if I increase this by 10%, and then if I do it by 20%. So for the percentage change, we can look forward the multiplying factor concept over here, and also the result which we have derived a plus b plus ab by 100 for the net change. So we are discussing few methods out here. So the first one, what I'm looking at, the method over here is using the multiplication over here. 1.1 would be the multiplying factor when you have a 10% increase. And when 20%, it would be what? 1.2. So with the help of 1.1 into 1.2, we can look forward to figure out the percentage change with the multiplying factor. So what is 1.1 into 1.2? That is 1.32. So the percentage change we can figure out as the multiplying factor minus 1 into 100. So what we're going to get over here is 32%. So we learned the successive formula also over here of two changes. So the second method we could have thought on this line of a plus b plus ab by 100. So we can figure out the answer not necessary using the factors like 1.1, 1.2. So we can look forward to use 10, 20, 10 into 20 by 100. So what do I get? 32%. Let me use two more methods out here. So instead of using the multiplying factors in the decimal out here, like 1.1, we did 1.2, we can also look forward the fractions out here. So that is going to make a little easy for us, the calculation part. So can you look forward to write like this, 1 plus 1 by 10, which is nothing but 11 by 10 into 5. Now on this, I'm doing a 20% increase. So the fraction involved is 1 by 5. So the multiplying factor would be 1 plus 1 by 5, which would actually become 6 by 5 into the value 11 by 10. So this further I can look forward to write as, if I simplify out here, that is nothing but 33 upon 25 pi. So again, we got the multiplying factor in the terms of fractions out here, 33 by 25 minus 1 if I do into 100 will give me the percentage change. So of course, we have done such methods like 1 and 3 in the previous percentage class also. So today we have learned a new method, that is the second one, with the result a plus b plus ab by 100. So we'll see where all we can use this result in a while. Now fourth, we could have thought on the lines of triplets also. So let's say you have a 10% increase. So what is the fraction involved? 1 by 10. So can I take the initial value to be 10? One increase on this, the value becomes what, 11? Now on the new value, they're saying a 20% increase. So I'm taking a new value to be as 5 because we have to calculate 1 upon 5. So let me take 5 over here. One increase, I do get what? 6. Now the common number I have to make is 11 and 5. So we're going to use the LCM approach over here. So can I do it multiplying with 5? So this also gets multiplied with 5, with 5. This would be multiplied with 11 throughout. So what do I get over here in the case of triplets? That is 1 is 50. In between, I had what, 55, and finally you had 66. So we can use the final value 66. Again, if I look over here, divide by what, 50 minus 1, f upon I minus 1 into 100 if I do. So what do I get again over here? 32%. So I have taught you these four methods. And depending on the problem, we are going to use the methods also. So over here, if I look, the method which were really comfortable was all four you can see, say over here, because the figures were 10% and 20%, right? So you have to make the call which method you're going to use depending on the percentage figures. So let me take another percentage figure for you guys and you'll understand which method to be used over here. So let's say if you have something like this, 9.09% increase, and then you have a 8.33% increase. So over here, we would try avoid the first method also converting into the decimal point. Even we'll try avoid a plus b plus ab by 100. That may not be that convenient. So you have to understand that a plus b plus ab by 100 may not be easy every time. Over here, we can look forward to go with the multiplying factor concept or maybe the triplets also. So what is 9.09 in the fraction? That is 1 upon 11. So my multiplying factor would become what? 1 plus 1 by 11. So that is nothing but 12 by 11. So on this 12 by 11, I have to increase by 8.33%, which is what? 1 upon 12. So my multiplying factor would be 1 plus 1 by 12. That would be nothing but 13 by 12. So ultimately it becomes a little easy by cancelling over here. So 13 by 11 I. So what is the percentage change I can look forward to calculate over here is nothing but 13 upon 11 minus 1 into 100. So this gives me nothing but 2 upon 11. And you must be knowing by now, after you have watched the percentage classes, 1 upon 11 is 9.09. So 2 upon 11 would be nothing but 18.18%. Or you could have used triplets also out here. So what is 9.09? 1 upon 11. So let me use 11, the initial value. 1 increase, I'll get 12. Now 8.33 is 1 upon 12. So there is no need to pick another number. On 12 itself, you can calculate 1 upon 12 easily. So one more if I have, the value becomes 13. So final is 13, initial is 11. So you get the same percentage change as we got with the previous method over here. So these two methods would have been convenient rather than going with the converting the 9.09 into the decimal number, or maybe using a plus b plus ab by 100. So I have shown you that a plus b plus ab by 100 may not be convenient with all the percentage figures. Now let's try see where all we can use the successive formula. So that application is important. And in the upcoming videos, I'll be coming up with the uh, solving problems of the successive. So do keep checking the videos on the channel CAT2IM by Manoj Maharaj. Now let's look one thing over here. We took the example of first increasing the initial value by 10% and then increasing it by 20%. See, remember one thing out here that the ultimate multiplying factor we had was 1.1 into 1.2 of the initial, right? So what I wanted to make everyone clear over here is that first you increase by 10 and then by 20, or if you do it first increase by 20%, or next would be increase by 10%. So doing 10% increase and 20% increase, or doing first 20% increase and then 10% increase, the ultimate multiplying factor is going to be same, which means that the percentage change is going to be same. So you can use either first 10% increase, then 20, or maybe 20 first and then 10. So over here, the factor would have been 1.2 in the middle, but finally, if you look, the factor would have been 1.1 into 1.2. So this is something which everyone should understand, that the order of the percentage changes does not matter. The net change in both the scenarios would come out to be same. Now, the other interesting thing you need to remember is that you can use the formula a plus b plus ab by 100, even if I do a decrease. So both could be decrease also. One increase, one decrease can also be there. So I'll take one example of, let's say, 20% increase, and the other is a 10% decrease. So figures are very easy. I'm using a plus b plus ab by 100. I have more methods to do it, but let me do it with the result out here, right? So I'm going to use with the sign. So whenever in the questions also they give you the word discount, so always make sure that you put the negative sign. So 20 minus 10 minus 20 into 10 by 100 if I do, this is going to give me 8%. Let me take another example where both the figures are negative, minus 20 minus 10. So again use with the sign minus 20 minus 10. Now remember, it is a multiplied with b, divide by 100. So minus minus would actually become plus over here. So what do I have is minus 30, and this would be plus 2. So minus 28% we are going to have over here. So this is what you need to understand. Now let me tell you that if you have more than two changes, how you can also work with the formula a plus b plus ab by 100. So if you just pick up simple numbers out here, 10% increase, let's say 20%, and then 30%. So the result a plus b plus ab by 100 can be applied if you have two or more than two successive changes. Remember that. And again, the order of the changes does not matter for the net change. So either you 10% increase, then 20, then 30, or maybe let's say if you do first 10%, then 30, and then 20, the answer would be same. So what you're going to do is you pick up two numbers, right? So let me pick up 10 and 20. So when I do it with 10 and 20, the net change comes out to be nothing but 32%. So I'll make a new problem now that from 10, 20 successive, net change is what? 32. So now you would have understood that how to use the formula A plus B plus AB by 100 of two successive changes for more than two changes as well. So there is no need to make formula for three successive changes, four successive changes, because that would be complicated. And if we can use the formula of two successive changes for more changes also, then why not you should use it, right? So if you look over here, 32 plus 30 plus 32 into 30 upon 100. So what do I get over here is 62, and this what? If I look 9.6. So this gives me 71.6% if I look over here. So one thing is also very sure that you're doing successive changes 10, 20, 30. So if I simply add 10, 20, 30, this comes out to be 60%. So one thing is very sure that my net change would surely come out to be more than 60%. So you can see it is coming out to be 71.6%. So one use of the successive we have seen when you have more than two or uh, changes over here, we can look forward to use that same formula A plus B plus AB by 100. Now I wanted to show you that you can also use the successive formula when there is a quantity which is a product of two or three quantities. So let me just give you some example of quantities over here which are product of two or three, like area of a rectangle, that is length into breadth, area of a triangle, half base into height, distance, speed into time, expenditure, price into quantity, volume of a cuboid, length into breadth into height. So you have the product of two or three quantities out here. So let me tell you how you can use the successive formula in such problems also. Let me create first question with all of you. See, area of the rectangle is length into breadth. So let's say the question talks about that there is a 10% increase in the length and a 20% increase in the breadth. And the question says, what is the percentage increase in the area? So of course, we can do with the basic approach also. Like we're going to calculate, this is let's say area old, length into breadth. Area new would be what? Multiplying factors if I use 1.1 into L, 1.2 into B. So if I wanted to calculate the percentage change over here in the area, so that is what? Area new upon area old minus 1 into 100, correct? So what do I get over here if I use area new as 1.1L into 1.2B and area old as length into breadth? So what is going to be left out is finally 1.1 into 1.2. That's a multiplying factor left out over here, minus 1 into 100 if I look forward to calculate. So this is going to give me what? 32%. So this is the basic approach what we have done. Now I wanted to teach you the successive concept also out here. So my problem could be, let's say, see, if you get this factor 1.1 into 1.2, you are going to get the same percentage change, that is 32%. If I look the problem like this, so second approach could be this, and this is what I wanted to make you understand. So whatever area old you have, that is length into breadth, okay? So on the area old itself, I am increasing it by 10%, and then new value I'm increasing by 20%. So what is the final value I'm going to get? 1.1 into 1.2 area old, which is nothing but 1.1 into 1.2 into L into B. So you actually got the same area new what you got in the previous question also. So when I'm going to calculate the percentage change, again I require the multiplying factor. which is same 1.1 into 1.2 compared with the previous question. So my percentage change would again come out to be same over here. That is nothing but 32%. So what I'm just trying to say that can we convert this problem of the first type into the second type and use the result a plus b plus ab by 100 if the figures are convenient to use. So over here we have used simple figures 10 and 20. So I could have done like this. So you would have understood by now where the successive formula can be applied. So I've shown you at two places. One is when you have two or more than two successive changes in the percentage, there you can apply a plus b plus ab by 100. And secondly, if you want to find out the percentage change in the quantity, which is a product of two or three quantities, you can look forward to apply the success formula. So I'll come up soon with the uh, video on the success percentage 2, where I would be taking examples. So do follow the channel Cat2 I am by Manoj Mahajan. Do share the video with as many aspirants so that they can benefit from it. Thank you so much.